Hi.
Hello?
Hello.
Hey, how's it going?
Hi, Javier. How are you?
Doing good. Yeah, sorry for the delay. I actually had to basically change the time just because my mom's actually in the hospital. Well, she
Oh,
was,
yeah.
so she got discharged. So that is what happened.
So we're going to change the 6 for the
Um,
live selection.
yeah, so yeah, we actually just changed. I think if you guys are okay, we can either keep it like
Uh-huh.
this, or we can either change it too. But it's just up to you guys.
I can do it.
Yeah. Hey, that's perfect. At 6 o'clock should work well for me.
Yeah.
That'd be great. How you doing there, Quentin?
Are you talking 6 o'clock on Thursday?
What was that, my man?
Is that 6 o'clock on Thursday?
Yeah. So yeah, I just changed it today. Just because what happened is that my mom was actually in the hospital. So she just recently got discharged. So yeah, I would have made it for 5, but yeah, unforeseen circumstances. That's all.
Okay.
Yeah.
Sorry about that. It's just
Yep, not a problem. No worries. So, I actually, since that happened, I wasn't able to do a lot of the readings,
uh-huh.
but I guess we can actually go through them if you guys would like to. We can go to the group of meeting quiz, and maybe we can put our minds together to see if we can come with the right answers.
We can whisper together.
Oh, right. Okay. So I guess is everybody there?
Yeah.
Awesome. All right. So we're just on question number. So I believe the two questions are just true and false, so we can answer those in our own discretion.
Mhm.
But number 3 is a question. So it says the total area under a normal distribution curve must equal. So I guess briefly, as I read through the readings, I believe it's 1.
Yeah, it's one.
Yeah. Okay. Perfect. All right. Under certain circumstances, a normal distribution curve can drop below the x-axis. True or false?
I think it's false.
Yeah, I think it actually is false too.
Yeah, because it's always horizontal or above the horizon axis, so it's false.
Okay. All right. All right. The question number 5. A normal distribution curve is symmetric. I believe that's true. I believe a normal one is, but if it's abnormal, I don't think it would be.
Yeah.
What do you? Yeah. All right. Perfect. So that's question number 5. All right, so this one I am a little bit, I didn't really read on this one, so I'm not completely sure. All right, so which of the following elements of the figure represent the z-score? So what would you guys say that one would be?
Mm,
Let's see.
okay.
I think it's C.
C? Okay.
Here, I'm gonna call you from my computer because this phone's making weird noises.
Yep, not a problem, man.
Okay.
All right, C. So what do you think? So it was Desmond? Is that correct, or
No, it's Dassel.
Dassel?
But
Okay.
I just go by Kim.
Oh, what was that? Sorry.
I go by Kim. You can call me Kim.
Oh, by Kim?
Yeah.
Oh, okay, perfect. All right. So what do you think?
I'm not sure, but
Yeah, me either. Not completely sure either.
Mhm.
I mean, if we look into what we studied, I think it would be that.
Mhm.
Number C.
Hey.
Hey. So Clinton, you said C. So I guess I'm actually not. So how did you get that answer, my friend?
I think it's, but I don't know.
Yeah. Okay, no worries, Dan.
We did this earlier. It's confusing.
I see. The proportion of greater women age is blah, blah. Let's see. I believe that you'd be right because it does show a diagram. The type C score into one of the two boxes along the rising axes of the graph. Curve only. So I guess we'll go with C. How's that sound? Yeah, but let's see. Using Apple to calculate portions, possibilities under a normal curve for the following elements. Please open. Okay, and practice using finding areas. Normal probability. Yeah, I believe it would be C. Let's see. Still question it. Yeah, I guess it would be C right there. I guess we can pause on that question and move on to the next one.
I think that, sorry.
What was that, man? Sorry.
Yeah, it's because A and B do not touch the line, and C is one, which is on the B or line.
Okay.
Kind of hard to understand it. That's how my friend explained it to me.
Oh, okay, perfect. Sorry, man. I need to plug in my headphones just a sec. All right.
Oh, I found it.
Oh, you found it?
Yeah.
Perfect.
If you look the lesson 5 number distribution and C 3.4.
C is 3.4. Yep,
There are 3 dots. You can see it.
Okay. For probability. Covering score probability using based area.
It is calculating percentile using a normal distribution.
Oh, no. Oh, okay. All right, I see it.
Yeah.
All right, so I guess that would be our answer then.
I think so.
Okay.
So what
Perfect.
do you
All right, so we're moving on to question number 7. Which of the following elements of the figure represent the probability that the Z score will be greater than 1.000?
I'm sure it's C.
Yeah, I'm pretty sure it would be C too.
No, it's B.
Sorry, E larger than 1.00. Okay, I guess we'll go with B.
Yeah,
Sorry, guys, I should have prepared a little bit more.
it's okay.
All right. Question number 8. According to the 6, 8, 95, and 99.7 rule, percent rule, what percentage of data from a bell-shaped distribution will be within 1 standard deviation of the mean? Write your answer as a percentage, such as 42, rather than a proportion such as 0.42. So this one, I actually am not completely sure how to do this one.
Oh, I saw it on the online textbook.
Okay. Yeah, I think I saw it too.
Yeah.
There we go. So now this is the rule. Approximately 68% of observation of bell-shaped distribution will be between E negative Q equals 7 meters.
Oh, it's 68.
68. And how did you get that answer, Kim?
So can you find the density curve?
Oh, in the textbook?
Yeah, on the textbook.
Yeah, I see it right there.
And if you scroll down, you can see the yellow box.
Oh, I see.
Yeah.
Okay, so for any bell-shaped distribution, and it shows that in the, so it says percentage is 42 rather than, and it's talking about the graph above that, right?
Yeah.
Okay. And you said it would be 68?
Mm-hmm.
Okay. All right. Oh, frick. I just switched it up. Okay, there we go. 68. All right, now we're moving on to the next one. Clinton, would you like to read that, my man?
Yes. Use the z-score from a standard distribution. Use the normal applet question. What proportion of scores will be between -1 and 1?
Okay. Between -1.
Oh, it's 0.683.
0.683. Oh, it's looking at the probability area. Yeah, okay. And it's saying for 1, right?
Sorry?
So I think it's saying for 1, right? Is that correct?
Yeah, it's correct.
All right. Wow. My mouse has been finicky. I can't even get the 1. What would it be? Sorry. So it'd be 0.6. There you go. Man, I can't get. Oh, actually, I can just type it in. Well, that's funny. There we go. Yep. So it's 1.645. Is that correct?
683.
683. Okay. 683. 683. There we go. Perfect. All right. All right, Kim, would you like to read the next one?
Yeah.
Okay.
Suppose that this comes from a standard normal distribution. Is the normal probability after to answer this question? The precision of the z-scores will be between -2 and 2.
Okay. All right, that seems easy enough. So 2 and -2. Wow. There we go. So I got 0.0455. Is that what you guys got?
No.
All right, I'm definitely doing this wrong. So I guess what it's asking for is putting in the z-score, right?
Yeah, right. And you need to click the middle one.
Oh, the middle one.
Yeah.
Okay, that makes sense because we're looking for basically the normal distribution.
Uh-huh.
Okay, yep, all right, I'm messing around. All right, perfect. It would be 0.9545.
Perfect.
Yep, all right.
No, it's 0.55.
0.55? Oh, yeah, because you're rounding.
0.955. Sorry about that.
Oh, not a problem, no worries. 0.5.
955.
955. Okay. Okie doke. Moving on to the next one. I think it's doing the same thing. So -3 and 3. 3. And what did you guys get for that one?
0.997.
Yep. Perfect. All right. Looking carefully at your answers to the last 3 questions, what do you observe? The values match the 6, 8, 9, 5, 99% rule as the Z score increases, the dot area between -Z and Z decreases, the probability double as you move from Z1 to Z2. That is a good question.
Definitely E, not answer.
Oh, I'm sorry, what did you say, Kim?
Answer.
Yeah, the area between. Yeah, that's right.
I think it would be.
Yeah, I think it would be Ale too, because I think it does match with it. All right, are we good with that answer, guys?
Yeah.
All right, perfect. All right. And who would like to read the next one? I can do it if you guys want. It doesn't matter to me.
Okay.
All right. The amount of protein that an individual must consume is different from every person. There are solid theological ideas that suggest that the protein requirement will be normally distributed in the population of the United States. The protein requirement is given in terms of a number of grams of good quality protein that must be consumed each day per kilogram body of weight. The population mean protein is requirements for adults is 0.65 grams p kilograms to the power of -1 and d to the power of -1, and the population standard deviation is 0.07 gp kilogram -1 and d -1. What proportion of the population have a protein requirement that is less than 0.60? Give your answer as the decimal accurately to 3 decimal places. Dang, that's a long question. All right. Okay. Every person there is out there ideas that suggest that protein will probably. Okay, I think I actually found an equation that we can actually use.
Okay.
So actually it's the one, it's actually 3.2.1 heights of, sorry, I'm not going to pronounce this right, Guianan woman. So basically that is just right below, if you look at normal probability computations, it's just right below that. And there's actually an equation that shows z equals x, take away u, divided by, I have no idea what that symbol is, but all of these represent, I think, the information that we're looking at. Native u divided by q. So what it's saying is that there's a standard deviation. Deviation equals 0.07, and then the mean is what? Portion of requirements. Okay, so it's 0.65 is the mean. 6.5. Then what was that? Oh, sorry, what was that, Clinton?
Wouldn't it be the 0.60 grams minus 65 grams, which is the mean,
Yep,
divided
that's fine.
by the deviation? The 0.0.
Yep, I believe that would be it, man. If that would definitely be it. Oh, did you already punch that in, my friend?
Hold on, I'm doing it.
Nope, no worries. So mean population, so mean would go to the position, which is U. And the mean for that is 0.65. Take away standard deviation. Yeah, 49. So you divide it by standard deviation. Standard deviation is 0.07. And now we're just missing.
Oh, I figured it out.
Awesome.
So the equation would be 0.06 minus 0.65 divided by 0.07.
Yep, I think that would be it. I'm just wondering the proportion. Yeah, they're talking about the population requirement that is less than. Yep, okay. All right. 0.6, take my 0.5 divided by 0.7. And then
And
did you?
measure is negative 0.71.
Yeah, that's kind of what I got too. Take away 0.65.
What'd you get?
So I actually got negative 8.68. And if I rounded that up, I can make it into 8.70. But it says give your answer in the decimal accuracy to the 3 decimal places. So mine would probably be 8.685 negative. What did you guys get for that answer?
Negative 0.714.
714?
Yeah.
And I guess you did 0.6 take away 0.65 divided by 0.07. Is that correct?
Yeah, right.
All right. All right, I'm going to do it again. Maybe I entered it in wrong. Let's see. 0.65 divided by 0. And what did you get, Clinton?
I'm being totally honest with you there.
What was that?
I'm being totally honest. Recalculating.
Oh, you're recalculating right now. Yeah, I guess that's the answer I get. I guess we can all be in agreement. So what did you get, Kim, again?
So this is not the end. We need to put this answer to the normal probability output.
Oh, so it's not the end. So we still have to do something else with this number. Okay.
So we need to put this answer to that score.
Man, so I guess I'll have to read again.
Okay.
All right. So what would we do with the number that we find from that calculation? So that's the time.
So the site that we use. Probability. that we use at the question 11, 10, 9.
Oh, so with this information, we would have to do it for all the rest of them. I'm sorry, guys. My computer speakers are not the greatest. So 13. I guess we're not quite sure what 13 would be, eh? Well, I guess if you guys want to, we could move on to another question since we're having a little bit of a problem with that one.
Okay.
All right. What question would you guys like to go to? Because I think that all these calculations for question 13, it basically goes all the way to 14, 15. I believe it goes all the way to that. So you need that answer to solve all those problems. Dang. All right. Well, all right. I guess 16 is a very similar question. Do you guys want to attempt that one? So, all right. So find the probability that a random selected person will have a protein requirement that is between 0.60 and 0.70. Hint, remember that to find the area between two values shaded to the left of each z-score, you calculate and then subtract the smaller area from the larger area. Okay? Make sure your answer is positive. This is the probability that a randomly selected observation will lie between two values. Give your answer as a decimal, accurate to 3 decimal places.
Sounds like that in the previous answer too.
Yeah, I think it's pretty much almost identical to the previous one. I mean, if you guys want, we could always study this on our own and then try to come with the solutions. I just haven't had as much time to kind of look at it all. I mean, it's up to you guys. If you want to keep on going, I'm down 100%. I just find that for myself, I just need to kind of research and kind of look through all the, kind of go through the textbook.
Yeah, let's do that. It's one equation or formula, and once we figure it out, we're going to be a piece of cake.
Yeah, exactly. Man, I apologize. I just didn't have as much time, for sure. But definitely, next week, I'll definitely do my best to research a lot more on the stuff that we'll talk about.
Well, not just your fault.
What was that, bro?
It's not just your fault. It's us too.
No, it's all good. Hey, that's what we're here for. As once we all research it, man, we'll be able to help each other out. All right, well, guys, it's great. And if you guys, I guess if all of us kind of study it and we want to meet up again, I'm definitely down for sure. Just let me know. And then what was that?
This is due tonight, right?
Yeah, so this one actually, oh, dang, yeah, you're right. This actually is due tonight. So, never mind. Good luck, and hopefully it works out.
Yeah, everyone's on now.
Yeah, that's right. Sorry, guys.
Okay, well, we'll prepare for Tuesday's meeting then.
Yep, that's right. I'll definitely make sure that I'm prepared for sure. I know that the first section, it was very easy. Like, it was super easy. This one just takes more time for you to search the information, that's all.
Yeah.
Yeah. But anyways, I will send this to the group discussion board, and we should be good to go.
Okay.
But,
Also, aren't you able to view the other groups' meetings too?
yeah, so you can actually view all the. I believe you can view all the other ones. Yeah.
So hopefully there'll be a video on, and if you guys get stuck, you could watch it so you can figure out what they did.
Yeah, that's right.
It's all the groups.
That's right. Hey, the information's there, man. So hey, why not? They'll help us understand everything.
Yeah, I think that's the whole idea of doing this, to make it look like a classroom. So
Yeah, I agree. Because even actually from one of my math classes, it's the same thing. I mean, like it's hard to do all the information by yourself without a teacher always being present. So it's always good to bounce off of each other's knowledge.
Sure.
Right. Well, guys, I hope you all have a good night and good luck. And I'll talk to you guys soon.
Yeah, hope your mom feels better.
Yeah, hey, thanks, fam.
All right.
Appreciate it.
Get us to on Tuesday.
Yep. So Tuesday, I'm good with anytime actually. Whenever you guys are available, we can either meet at 5 p.m. Mountain Time, or if you guys need it later, just let me know. But we can set it for 5 p.m. if everybody's good.
To have that 6. If you're meeting later, then I'll just do the video.
Oh, what was that, man?
I said my meeting, other meetings at 6 on Tuesdays. So in case you guys can later, I'll catch up and watch my video.
Yeah, not a problem, man. That's not a big problem. I'll just text me, and then if anything happens, then we'll definitely scale it out like that.
Okay, perfect.
Perfect.
That's good.
All right, man. You guys have a good night.
You too.
Yeah, you too.
Hey, take care.
Bye.
Bye.